Hello everyone, in today video we are discussing about peak detectors. So how peak detectors came into, so we know that in conventional method the traditional AC voltmeter we were having, which was used for calculating the RMS value for sine waves. That's why we say that as a conventional or traditional AC voltmeter designed to measure RMS value of pure sine wave, it was only calculating the sine waves. But AC voltmeter cannot find non-sine wave form because it was not able to calculate or any values for non-sine waves. By using peak detectors, we can find the peak value of non-sine waves, and peak detectors are solution of AC voltmeter, we can say. So here we have peak detector circuit. So here we have the diode 1 or diode, we have only one diode. This is a capacitor C and it is MOSFET switch. So this is MOSFET switch. Okay. So here we have voltage follower. So we can, whenever we are giving input signal, we have the diode which is having the capacitor connected to it, which charges and discharges through the MOSFET switch. So here we can say a peak detector detects and holds most positive value of input signal, and capacitor will retain its charged value unless until it is discharged with switch. So unless and until the capacitor is discharged from the MOSFET switch, it will be charged and retain its value. And this peak detector will hold most positive value. And next point is, during positive half cycle of input, diode conducts and capacitor charges. So during this half cycle, it is diode will conduct and capacitor will charge at peak value of the input it will take. Then op-amp will be connected as a voltage follower to its output voltage, which will be equal to current drop across the capacitor. And next, the peak value will constant until and unless we get next highest peak value for the input. So till we get the another highest peak value, the previous one will be kept constant, and for negative input the diode will get reversed. So in negative situation the diode will be getting reversed. So next we have modified peak detectors. So modified peak detectors, what is the difference? We have two amplifiers, that is op-amp, and we have two diodes, and we have total two resistors. So what does this op-amp A1 will do? It is connected as a voltage follower. See, it is directly connected, this op-amp is directly connected to the voltage follower, which represents the impedance to signal source, input signal source, and A2 act as a buffer between capacitor and load. So A2 is acting as a buffer for amplifiers between capacitor and the load. V0 is equals to voltage on capacitor, which is nothing but our peak value of the input occurred at that time. So whatever input we got that time, the voltage across capacitor will take that. Whenever input signal has higher peak than present one, capacitor charges to new input value. So till new highest peak value we get, the capacitor keeps the value constant. If once a next peak highest value is coming, at that time what will happen? It will charge to new highest value. When input level gets dropped, then capacitor retains peak value of input as diode 1 and get reversed biased. That means when it is getting negative or some lowest value, that time this diode will get reversed. And D2 diode protects the amplifier A1 from going into negative saturation. This is why the diode 2 is working as buffer. Okay.